Hello. The following example is example 4.1.6 from your notes. This is dealing with finding the inverse of functions. Remember, the definition of inverses are that f composed of g of x is equal to x and g composed of f of x is equal to x. In order to find the inverse function, what you need to do is you need to realize, first of all, that in order to have an inverse function, a function must first be one-to-one. That's the reason we talked about one-to-one functions. Now, this is actually an if and only if statement. If a function is one-to-one, then it has an inverse. Also, if a function has an inverse, then it's one-to-one. Also notice over here that f composed of g of x is actually just function notation. That stands for a y. And the same thing over here for g composed of f of x. That's also just function notation. That's also a y. In other words, y equals x and y equals x. In other words, x and y can be reversed, actually. In fact, that's the definition of an inverse function. The x and the y values switch each other. Over here, let's look at f. The first thing you want to ask yourself is, does f have an inverse at all? In other words, is it one-to-one? It's definitely a function because none of the x values repeat themselves. But remember, the definition of a one-to-one function is that none of the y values repeat themselves. Notice that here there's a 1 and here there's a 1 for the y values. The problem is that this 1 is corresponding to both the -2 and the 0 at the same time. Therefore, this f function is not one-to-one. By the same reasoning, these 2's make this function also not one-to-one. Therefore, f doesn't even have an inverse. Let's look at g. G, yes, it's obviously a function, but is it one-to-one? It has the y values of 1, 2, 3, and 0. Notice that none of those repeat themselves. Therefore, g has an inverse. So the inverse of g, that's what this -1 means. It's just going to be another set of coordinates. Except this time, reverse the order in which the x and y appear. So for the first coordinate, it will be 1, 3. The second coordinate would be 2, 0. The third coordinate, 3, 2. And the fourth coordinate would be 0, 4. Notice that this is actually a function. All of the x values do not repeat themselves. That's why g had to be one-to-one to begin with in order for it to have an inverse function. Let's look at what happens if we try that with f. So the inverse of f would be 1, -2, 0, -1, 1, 0, 2, 1, and 2, 2. The problem here is that this 1 and this 1 repeat themselves. In other words, this is not a function. That's why the function must first be one-to-one. So, f does not have an inverse. G does, and its inverse is 1, 3, 2, 0, 3, 2, and 0, 4.